Hello, in this video we're going to go over the relation between multivariable cyclic functions and functional equations. I have other videos discussing functional equations and cyclic functions, which I will put them on the screen right now so you can check those out. But this would be another example. This is in multivariable case. So they gave us a functional equation that they're asking us to find all of these functions. So the first thing you want to do is to plug in some different values of x and y. So let's say you want to find f of 1, 2. Then you plug in 1 for x, 2 for y, and that would give you something in terms of f of 2, 1. So you realize that in order to find f of 1, 2, you need to find f of 2, 1. So then it makes sense to plug in 2, 1. But when you do that, you go back to 1, 2. Which may in the beginning seem like unfortunate, but in fact we get a system of equations involving two unknowns, and then we can solve that system of equations. So can we do the same thing for any xy? And the answer is yes. So what we're going to do is we're going to take the functional equation that is given. We are going to substitute x by y. We're going to substitute y by x. We get a system, and then we're going to solve. And this idea is called idea of cyclic functions. So the function that we take, phi of x comma y equals y comma x, this is a cyclic function. So if you apply this function twice, it goes back to the identity function, which is why it's called a cyclic function. So we substitute x comma y by y comma x. So when we do that, we get 3f of y comma x plus 2f of x comma y equals y plus x squared. Now we get a system. So we obtain the following system. One of them is the one that is given, 3f of xy. This is the original functional equation, and the other one is the one that we just found, 3f of y comma x plus 2f of x comma y equals y plus x squared. Now I would like to solve for f of x comma y, so I'm going to eliminate f of y comma x. I'll multiply the first one by 3, the second one by -2, so that the coefficients of f of y comma x become negative of each other, and then we can simplify that. We get 9f of xy on top minus 4f of xy at the bottom. We get 5f of xy equals 3x plus 3y squared minus 2y minus 2x squared. Dividing by 5, we get that f of xy equals 3x plus 3y squared minus 2y minus 2x squared over 5. Keep in mind that this shows that if f of xy is a solution to the functional equation, then f of xy is equal to 3x plus 3y squared minus 2y minus 2x squared over 5. It does not guarantee that this is in fact a solution to the functional equation. So therefore, we are going to substitute that into the original functional equation and see if it is a solution to the original functional equation. For this function, if you evaluate 3f of xy plus 2f of y comma x, we get 3 times this, which is 9x plus 9y squared minus 6y minus 6x squared over 5 plus twice that, but I'll have to swap the x and y. So 6y plus 6x squared minus 4x minus 4y squared. Now we're going to look at the like terms and combine 9x here and 4x here. That gives us 5x over 5, that's x. Then we have 9y squared minus 4y squared, that gives us 5y squared divided by 5, that's y squared. Then we have the 6y and 6y that cancel, negative 6x squared and 6x squared cancel. And in fact, we do get what we wanted to get. So thus, the only such function is the function that we found. F of xy equals 3x plus 3y squared minus 2y minus 2x squared over 5. So this is the final answer. If you like this video, make sure to comment below and let me know what kinds of videos you would like me to make. My focus is on preparing students for mathematics competitions, and make sure to subscribe to the channel. And I will see you in one of the other videos that I put on the screen.